Okay, so today we're going to be looking at working out the area between a curve and the y-axis. Okay, so last year at Higher, all your area underneath curve questions would have been related to the x-axis, finding the area between a curve and the x-axis, whereas we're going to look at what happens or how we do it for finding the area between a curve and the y-axis. Okay, so it's basically the same process. So what we do is the area between a curve and the y-axis is the integral between two limits b and a. We rearrange our function so that we have x equals, okay, and we differentiate with respect to y. So last year, your formula to work out the area of the curve would have been y by dx, okay? Whereas here we're just swapping it around because we're doing the y curve. So when we put in our x function, we're going to get the y's out of it, and we just integrate it with respect to y. Okay, same rules apply as what we done last year. Okay, so the sort of picture to have in mind when doing this. Okay, so if that's my y-axis, my x-axis, if I've got a curve, let's say it's going like this, and I want to work out the area of just that, but there between that and the y-axis, with b and a being my limits. Okay, so that's the sort of picture to have. Okay, whereas if I flipped that or rotated at 90 degrees, it looked like one of the things that you'd have seen last year against the x-axis. Okay, so same principles apply. So we'll look at a couple of examples just to show you how that works there. Okay, so example 1, we're going to find the shaded area enclosed by the y-axis and the curve y equals x minus 4 to the power 3 between y equals 1 and y equals 8. Okay, so that's going to be an example of the question. We're going to find the shaded area enclosed by the y-axis and the curve y equals x minus 4 all bracket cubed between those limits there. So what the picture of this would look like, okay, it's very similar to the diagram I've actually got above. Okay, that would actually be a curve that goes something like that. 8 would be there, 1 would be there. And I'm working out that shaded region there. Okay, so that's what I'm doing. So, start my solution. So the area formula, limits b and a of x dy. For that, for us, it's going to be between, let's say, 1 x dy. Okay, so you'll know this from using things in differentiation. So as we cannot, you'll have to write this down for every step. Let's just put a wee additional note there. Okay, so as we cannot integrate x with respect to y, therefore we need to rearrange the equation of the curve. Okay, so I need to rearrange so that I get x equals, therefore I'll substitute that in, all the y's will be a part of my question. So, starting off with x minus 4 cubed, we know that equals y. That was my curve. If I take the cubed root, therefore I get x minus 4 equals y to the power of a third. Add 4 on the other side. X equals y to the power of a third plus 4. Okay, so that's what my function for x would look like if I just rearrange for that. So, area between 8 and 1, y to the third plus 4 dy. Okay, I've just substituted x in my formula for what x equaled there. You okay with that step there, yeah? And now you can see I can actually integrate this. I'm just integrating my respect to y's. Okay, so I'm just treating these like how I would have it higher last year. Okay, so if I integrate both of them there, I'm going to get y power 4 over 3 quarters of it. Okay, so you flip the fraction by divides. 3 quarters y power 4 over 3 plus 4y between the limits 8 and 1. Okay, you okay with that integration here? Putting your limits in. Okay. So that's the first limit put in, 8. Then I'm subtracting the second limit, and I put 1 into it. I've got that there. Okay. If I've done this without a calculator, okay, which this could be, and this could be a fair one disregarding the numbers they gave us, okay. 8 to the power 4 thirds, okay, so the cubed root of 8 is 2 to the power 4 16. If I then divide 16 by 4 times it by 3, I get 12, okay. So 12 plus 4 lots of 8, so that's 32 plus 12, which is 44. So 44 for the first bit. Then, okay, we've got fractions to deal with here, but I've got 3 quarters, 1 to the power of that is just 1, plus 4. Therefore, I get the answer 4 and 3 quarters. Therefore, my answer is 39 and 1 quarter, okay? Because it's an area, units squared. Okay, remember that? Units from higher last year, yeah, units squared. Okay, so same applies. So we're okay with that. So this bit here shouldn't be much new, just apart from it's just with a y variable. It's this bit here that we need to do just to rearrange to get it in the right format to use that. Are we okay with that first example? Yep, look at the second one. Okay. Okay, example 2. So, just going straight to my answer, I'll write the question. So we're going to find the area enclosed by the curve y equals x squared between y equals 1 and y equals 4. Okay, so that's the question. Find the area enclosed by the curve y equals x squared between 1 and 4. Here though, what's crucial is that I'm saying x is always greater or equal to 0. Okay. Reason being, if I draw just x squared, that's not a very good example, I've made a mess of that, I'll try that again. That's y equals x squared. Okay? Now, if I just treat x as both positive and negative, if I were to find the area between, say, 1 and 4, so let's say 1's there and 4's there, then you can see I've actually got the shaded region twice, don't I? The exact same thing would happen, okay? However, in my calculation, it would cancel each other out because it's either side. Okay, so that's why it's explicitly said x greater than or equals 0, so that the bit I'm only interested in would be the positive side. Okay, so that's what I'm looking at there. Okay, does that make sense? Okay, so that's why that x greater than 0 is part of the question. Okay, so therefore, go to the solution. So a equals b, a is your limits x dy. Okay, well if y equals x squared, then x equals square root of y, okay, which is y to the power of half. Therefore, limits between 4 and 1, y half dy. Oh, sorry, not those type of brackets anymore. So if I integrate that, okay, I got power 3 over 2, so I get 2 over 3 y to the power 3 over 2. So now it's 4 and 1. Put the limits in. Okay, so what would that give me? Square root of 4 is 2, to the power of 3 is 8. 8 times 2 is 16, so that's going to give me 16 over 3. Take away 2 over 3, which is 14 over 3 units squared. Okay, so I've got my answer for the area there. You okay with those? Yep. Any questions? Okay, perfect.